Welcome to this explainer. It's really easy to think of database storage as pure software magic, just data floating around in the cloud somewhere. But today, we're going to strip all that magic away and look at how things actually work under the hood of an Oracle database. Let's dive right into this. How does your data physically reach the metal? Because at the end of the day, every single byte of that logical data has to be written to a physical spinning hard disk or a solid-state drive somewhere, right? Beneath all those slick applications and cloud interfaces, it really is just raw data. The database is essentially acting as a master translator. It takes your logical commands and transforms them for physical storage, serving as the ultimate bridge between your digital data and the physical hardware holding it all together. To really grasp how this translation works, we gotta look at blocks. See, your operating system reads and writes data in its own specific chunks. We call those OS blocks. But Oracle doesn't actually use those directly. It speaks its own completely separate logical language using Oracle data blocks. Now, you might be wondering, why the separation? It all comes down to flexibility. To make sense of this, think of your database like a massive, well-organized library. You wouldn't just dump millions of loose pages on the floor and hope for the best, right? You organize them. And Oracle does the exact same thing with your data. To keep everything straight, Oracle builds a really neat hierarchy from the ground up. We start with data blocks. Those are your individual pages. Group those up and you get extents, which act like chapters. Build those up further into segments, which are your full books. And finally, they sit in tablespaces, which are essentially your bookshelves. So, starting at the absolute bottom, think of a data block as a single page. It's literally the smallest piece of data Oracle can read or write. It's the absolute minimum unit of database input and output. When Oracle wants data, it doesn't ask for a single line. It always requests a full data block, period. And because Oracle cleverly separates these logical blocks from the physical OS blocks, your applications don't actually need to know the exact disk addresses. That is a massive advantage. It means your data can be striped, spread out or mirrored across multiple physical drives without confusing your applications at all. Moving up the chain, when your database needs more room to breathe, Oracle dynamically adds chapters. We call these extents. An extent is really just a specific collection of those data block pages we were just talking about. What's super interesting here is the flexibility. When these extents are created, they do not have to be sitting right next to each other physically on the hard drive. They don't have to be touching. Oracle just dynamically grabs free space exactly when and where it needs it, keeping things incredibly efficient. Now group those chapters together, and boom, you've got a segment, the entire book. Say you have a table packed with customer data. All the extents holding that data make up one single data segment. If you decide to build an index for it, well, that gets its own completely separate index segment. Finally, we place those books onto a table space, our bookshelf. This is the logical container that physically hooks right into your actual data files on the disk. You group related segments here to make administration a breeze. Oh, and by the way, these tablespaces come in two flavors: small file, which spreads your data across many smaller files, or big file, which just dumps everything into one colossal data file. All right, so you've got the library structure down perfectly. Now, if you are gearing up for an Oracle certification exam or honestly just managing a real-world system, you're going to want to pay close attention here. These next few mandatory rules are exactly what you need in your back pocket. First up, burn this number into your brain: 8. 8 kilobytes is the default size for an Oracle data block. You set this right when you create the database, and honestly, for most standard setups, 8 kilobytes hits the nail on the head. But of course, you can absolutely tweak it if your specific workload demands it. Next, let's talk about the system and sysocs tablespaces. These are non-negotiable, mandatory. They hold the data dictionary, which is basically the brain of the whole database. You absolutely cannot drop these, and no, you cannot make either of them read-only. Plus, system, that can never go offline. Sysocs acts as a helper, so it can go offline, but only for very specific recovery tasks. And a quick pro tip: do not, under any circumstances, store your application data in these. So, we've seen how this logical storage totally abstracts the physical disk. But I want to leave you with this final thought. What block size does your application actually need? If you're running massive data warehouse tables, a larger block size is going to be a game changer. But if your app is hammering out rapid, random reads and writes, a smaller block might actually give you a massive speed boost. Think about how your application actually touches the disk and optimize for it. Thanks for tuning into this explainer.